Okay, we're recording. Hi, everybody. Thanks for joining. I think it's tough for some people. I know that I've heard a lot of comments about Zoom burnout, but hopefully you're here to get a lot of this user meeting. I mean, what we're trying to do in this meeting is to principally educate people trying to use Kubernetes on top of VMware infrastructure. And even if you're prone to Zoom burnout, I heard a great comment, or I saw it on Twitter, saying that, look, in these times of COVID where everybody's tied up working at home, you could either come out of this when it's over in the worst shape you've ever been, or you could buckle down and come out of it as ripped as you've ever been in your life. And that applies to your physical condition, but I think in many ways you could use that same principle with regard to your mental condition, where you can take this opportunity to learn new things. And I'm hoping maybe today's presentations in this user group will help that along, where you can come out learning new things. And even if you're suffering Zoom burnout, maybe pay attention. Hopefully this is good enough that you're not diverted and you come out of this learning something. We're going to start. This was based on a request from Bryson at the meeting last month that we cover load balancing for an on-prem situation. Bryson doesn't seem to be here, but maybe he'll join late or catch the recording later. So we're going to start. I'm just going to rip through some slides and turn this over to my co-host today, Steve Sloka, who's an expert on this subject. But let me just share a 101 for people who maybe need this on what is a load balancer. Excuse me, I'm going to have to find my, got too many windows open. I've got to find something. Okay. So what's a load balancer and why do you need one? Well, you can host apps and services on Kubernetes, and at times you want to expose this to the outside world, people coming in over the internet or people outside the Kubernetes cluster itself. This load balancer could also serve a secondary purpose of distributing requests across healthy servers and pods. You may or may not need that, but it's potentially available if you do. Now, when you're in a public cloud like AWS, Azure, DigitalOcean, GCP, or any of the others, this is relatively easy because the public cloud itself would host a load balancer as a service. Now, you pay for this based on usage typically, but it's there. When you move to an on-prem situation, whether you're on a hypervisor like VMware infrastructure on bare metal, this load balancer as a service isn't there unless you put it there. So what we're going to talk about today is your options when you're in a scenario where you need one, and you might not always need one, but if you do, what can you do to get one? Now there is an aside here of load balancing can potentially cover what they call north-south or east-west. This is based on typical diagrams of network infrastructure. So what we're talking about here is principally going to be north-south, meaning inbound connections outside your Kubernetes cluster that might come from the internet, might come from some WAN connection that isn't technically the public internet, but something from outside, versus internal things where your Kubernetes hosted services within the cluster are talking to one another. That in a typical network diagram would be designated as east-west. Now, Kubernetes itself has something called a service resource that handles the east-west and maybe can get that done. But even if you use that, you would typically build up a service that you would then need to potentially expose north-south, or if you wanted to allow outside the cluster users to consume that. And you would use Steve, the Kubernetes. Yes.
Yeah, are your slides supposed to be showing at this point?
Yes.
They're not showing.
Oh, okay. Excuse me. Just a minute. Okay, sorry about that. I'm going to post this deck after, so I'm not going to go back in the interest of time, but you get the idea. North, south, east, west. Can you see it now?
Yes.
Okay, great. And Kubernetes has something to handle the east-west, or at least a facade resource called a service that can do that. The CNI might enter into the actual implementation of that. When you get to load balancers, there's also something called Ingress, and Steve is going to cover that in just a few minutes when I get off the stage. But potentially you don't need a load balancer in the sense of a network load balancer. Maybe something called the Kubernetes Ingress could do it for you. The distinction is, and this distinction can be a little bit smoky, if you will, because there are some load balancer Ingress solutions that take on both of these jobs. But Ingress was initiated in Kubernetes years ago, back in 2015, I think. One surprise here is even though it dates back to around 2015, it's still marked as beta. And it was designed to work with these things called reverse proxies that have been popular before Kubernetes. The distinction is that an Ingress would dig into the contents of a packet, like a URL, to sniff out a host name or something in the string and use that to steer traffic. Whereas the L4 load balancer is looking for things like IP address port to steer traffic. So one is inspecting the content of a data stream. The other is inspecting just the wrapper. You can have both at the same time, and in many instances you would need or want both at the same time. There are a lot of these solutions. They vary in feature sets. You can see some of them here, but there are a lot of differences in these load balancers. They come in categories of hardware-based, like an F5. If you've got the money, the power, whatever, they might be potentially expensive, but F5s for a big on-prem might be viable, desirable. Once again, if you're cloud hosted, the cloud provider typically offers one. If you're on-prem and not using hardware, there's a lot of software solutions, both open source and not. I tried to survey these, and these things are links when you get the deck so you can learn more. I may have miscategorized these, so some of them I found links saying they were open source, but if I couldn't find the actual source within the top 2 links, I began to get suspicious. Some of them are come in bifurcated versions where they have an open source with less features and then a commercially supported. One element here with load balancers is high availability. With regard to one of these load balancers, MetalLB on Kubernetes, they say for high availability, you want a load balancer in front of the Kubernetes API, but this presents a chicken and egg issue of, what goes first. And I posted a link here to this MetalLB issue. The other consideration when you're going big on-prem is that you can potentially use DNS to accomplish some of these. And if you're geo-distributed and wanted to cache things close to where the user is, this becomes very complicated. And I've got a deck link here that goes into way more detail, but just wanted to throw that out there. So at this point, I'm going to turn it over to Steve Sloka. Steve will introduce himself, but I can say that Steve and I did a presentation together at KubeCon North America back in November on a subject related to this that you might want to see from the KubeCon recording, and I'll put a link to that in the notes later. So I think I stopped sharing. If you want to take over and share, Steve, you can have the podium.
Sure. Let's see if this works. All right. Do y'all see a terminal?
Yes.
All right. Let's start there. Michael, did you want to say anything about anything before we get started, or you want to jump in?
No, I mean, we can probably say that, Steve is one of the maintainers of Contours, which is an open source upstream Ingress controller started by Heptio/VMware and maintained by VMware. And we're actually under the final step of donating Contour to CNCF. So it's going to become an Ingress controller governed by CNCF. But yeah, Steve, take it.
Cool. All right. Yeah. So thanks for the intro, Stephen. And thank you, Michael, for that. So this is a quick, I don't know, I hope I have 1/4 of slides and the rest is demos. If you've seen me before, I like to just make everything demoable, which is more fun. So I'm just going to give you a quick backdrop as to what Ingress is. We'll chat about what an Ingress controller is, again, just to help take Steve's intro and one step further, just again, level set the audience. I'll bring up this CRD that we wrote for Contour just so you understand what it is when we go use it later. And then we'll just do a bunch of demos and stuff. We can skip this. I've done Kubernetes. I work at VMware. Come find me. I'm Steve Sloka everywhere. Cool. So what is Ingress, right? When I think of Ingress, generically, I think of it as just incoming, right? We want to think about getting traffic from outside the cluster into the cluster. And the generic example is always, I have this internet traffic and I want to send it to some sort of service or application in Kubernetes. Ingress itself is just a configuration spec. So it's just a way to define how this traffic should route from point A to point B. And then an Ingress controller is what actually implements that configuration. So it looks at that configuration on your cluster and then actually, wires the bits together when requests actually come flowing through. So why use Ingress, right? Why not just use load balancers all over the place? Well, the first thing is you get traffic consolidation, right? So all of your traffic can now filter in through a single entry point. You don't have to deal with lots of different node ports in your cluster, lots of load balancers. Things can get expensive, and then things just get difficult to manage, right? The more complex the system is, the harder it is to maintain. With the consolidation, you also can consolidate all of your TLS into one place, right? So your certificates and all those secrets can now live in one place. You don't have to deal with distributing them out across many different applications. And when it comes time to roll them and stuff, again, it's easier because it's all in one spot. You can abstract yourself away from your environment. So just like Kubernetes abstracts itself away from different components, you can, hopefully the goal here is to abstract yourself away from your environment, right? So you shouldn't have a deployment file that says, this is my Ingress for my laptop, my Ingress for AWS, et cetera. Now there are places where that contract breaks, but for the most part, I think that this is a great step forward to have this abstraction. And we also get this idea of path-based routing, right? So as Stephen mentioned, this is that L7 router, that layer 7 application layer routing, right? So we can inspect the requests coming in, and we can do more than just route on an IP and port. We can look at the /foo/blog and the request and take action on that, which is cool. All right, so this picture here explains just basically what we just said, but with a picture, so something easier to understand. So again, traffic comes in, we're going to have some sort of load balancer in front, as Steve mentioned in the beginning. So we just need this load balancer to basically send traffic to a set of envoys. So in Contour's case, we use Envoy as our data path component. So Envoy is a CNCF project. It came out of the folks at Lyft. And it's a high-performance C++ based proxy, and that's why we use it. Contour, in this case, is the Ingress or the XDS server or the controller for Envoy. So we give Envoy enough information to basically go find Contour in the cluster. And then Contour's job is to look at the cluster and find things like services, endpoints, secrets, Ingress objects, HTTPProxy, which is our CRD objects, all those different information bits. When it finds them, it builds a new configuration and passes that information down to Envoy. So we can do that without restarting Envoy, which is a big win of Envoy. So basically, yeah, request comes in, hits some sort of load balancer, Envoy gets it, and then it routes it to your application. So this is the generic example. You could also take Contour out of this picture and swap in any other Ingress controller. I think this picture would still hold up pretty well. Maybe different components under the hood, but essentially the same idea stays. Cool. As Steve mentioned, there's different ways you can attract traffic to Envoy. I'll skip this since we talked about it. He has actually some more things in his slides, so that's probably a better slide. I'll just go on through this. All right, so HTTP proxy. So this is our CRD or custom resource definition. So this is our way of looking at some of the limitations we have or shortcomings with Ingress today. If you've followed the project for a while, we came from this idea of this thing called Ingress route, and then this CRD is a successor to that. And why we did this, right? So we did this because we wanted to help support this idea of multi-team clusters, right? We want to have lots of users in a cluster self-manage their own Ingress objects. It's very easy today with the V1 Beta 1 Ingress to have two different teams, two different users take down production, and we've seen that happen before, just based on how the spec is designed. So this CRD is written around allowing users to solve that problem. We can do that through this idea of this delegation of routing. And more details on this could come in different talks. I won't spend too much time here. But the idea is that we can get permission sets of that path or domain and let users then self-manage based on this permission set that we can kind of configure. The other big thing we wanted to help solve is this way of having a common configuration place for certain things. So things like service waits, load balancing strategies, request timeouts, all those sort of parameters that don't have a place in the spec today, they typically end up as annotations on your objects. So we wanted to find a way to put them into the configuration object without having to annotate everywhere. And the last thing that's kind of cool is we have this idea of this delegation of secrets. So if you're familiar with Ingress today, if you want to terminate TLS out your Ingress controller, you've got to have a certificate or a secret to reference. And if you have that object across many different namespaces, you've got to copy that secret there many, many times. So as there's a maintenance nightmare, there's also a security issue, right? Because you're exposing that key to users that may not, or shouldn't have maybe access to that secret. So we can have this way where users can self-manage their fully qualified domain names, but not have physical access to the secret. So we can delegate off that secret across the cluster, which is kind of cool. Cool, so that's enough about the CRD. Again, I just want to introduce it so when we looked at it later here, you're all familiar with it. Cool, so let's bring in another thing here, right? So Contour, again, it's an Ingress controller. Its job is to proxy traffic, north-south into your cluster. Gimbal is a tool we wrote to help kind of extend that functionality, but extend it out over multiple clusters, right? So instead of looking at just having traffic hit a service or a set of pods in your cluster, we want to now direct traffic out across many different clusters. So originally we targeted Kubernetes and OpenStack for this, and then I have some code. I actually need to push a PR. We can do this now with vSphere as well. So we can target VMs running in a vSphere cluster. So here's kind of how Gimbal looks, right? So the idea is that we have these discoverers, and the discoverers are just simple controllers. And they go look for these services and endpoints in these upstream clusters. So I guess in this case, here's OpenStack, right? So this discoverer knows how to talk to the OpenStack API, and it'll go find all the VMs and load balancers that exist in there, and it'll copy those endpoints into this Gimbal routing cluster, right? So we'll actually create services and endpoints in Gimbal, again, which is running Kubernetes. We'll create that in this Kubernetes cluster, and we'll map those to teams. So we'll say a namespace is a team, right? So all of the things that match, say, app team 1 in this example, from each different cluster, right? It could be across VMware, Kubernetes, or OpenStack. All those different endpoints should live in the same namespace, right? Because the idea is that we're categorizing them together as the same team. Once they're there, then we can create some Ingress configuration here in this Gimbal cluster, and then we can set routing traffic all over the place, right? So we have our load balancer sending traffic to Envoy, and now once it hits this Gimbal cluster, then we can send traffic out back to whatever endpoint it could be. It could be an endpoint in the cluster or an endpoint off cluster, meaning an OpenStack VM or a vSphere VM, that sort of thing. That's all the slides I have. Anyone have any questions until we just do this for real? And that was kind of quick. Okay, cool. So I'm using, here in my house, I have Unify. So I'm just again proving that this is all real. So this is actually my Unify gateway controller. So I'm running a security gateway, which connects to my garage, which then runs to my bookshelf, then runs into my desk. So now I've got 3 different hops. Then I've got some wireless stuff. So that's my networking gear that I've got running. What I've done is I've deployed, I have vSphere running here as well under my desk. Here's that machine. So this one's running a couple things, right? So I've got a couple VMs. These are my crazy cool VMs. I've got Web01 and Web02, and also this Windows server. And then down here, I've got some clusters, right? So this is actually, I spun these up using Cluster API. However you do this is up to you, but this is what I use just to, again, be transparent. So what I want to do is I want to send traffic into this Gimbal routing cluster, and then we'll do some routing out to different places. Right, so to get traffic into my cluster, I have to then set up some sort of load balancer, right? So again, I'm using Metal LB. So on this Gimbal cluster, I can show you. So if I get pods, namespace, Metal, oops. There we go. So here's my Metal LB system. Hope that's big enough for y'all to see. So here I've got the controller running and then a speaker, right? And each speaker runs on every host in the cluster. So these match to the nodes I have running in my Kubernetes cluster. So here you can see, again, I've got those 3 different nodes, or 4, I guess, if you count this one. And then out here in my Unify system, what I have is I can show my BGP, right? So I'm using the BGP routing method. Again, and here are the 3 nodes in my cluster, this .102, 110, and 140. So this is how I'm directing traffic to Metal LB, and then Metal LB is going to dish out my IP address, right? So let's get rid of this real quick. And then I will show you, I have Contour deployed. So if I get services in Contour, or Project Contour, what you'll see here is this is my Envoy service, right? And it's type load balancer. And you can see here I got an external IP of 10.53.131.10. So this is the subnet that I have exposed out to my MetaLB. So it gets the whole 10.53 network. So again, when I created the service, MetaLB went and provisioned this for me. And then with all the routing in my router and everything, I have now a routable IP address. From there, again, just to give you what's going on, I added a DNS entry. So I've got a DNS server running. So if I do an NS lookup on that address, actually, sorry, I'll do it the other way. My domain is pixelproxy.net. You'll see here I got a response. I guess I got to work on my reverse there. So my reverse isn't working, but the front works. Cool. So this domain name or this address now resolves to this IP address, which is pointing to Envoy, right? And that's what I really need. I need to get all of my traffic driven to Envoy. Once it's there, then the hard part's over, and then I can just configure routes however I like to do it. Okay, cool. So now that I've got my infrastructure, I've got my cluster running, let's set up some routes and stuff, right? So if I go ahead and take a look at, if I get proxies and all namespaces, you'll see I've got nothing on here, right? So my cluster is completely empty. So a request, if I did a request to that load balancer, it's just going to fail, right? Because right now Envoy actually doesn't have any listeners open because there's nothing configured. So let's go configure something. So let's start here. So we're going to start with this idea of this thing called a root proxy, right? And this is basically the fully qualified domain name proxy. You'll see here I have that here. This is the pixelproxy.net. So what I'm going to do is I'm going to create a namespace in Kubernetes called root proxies. And I'm just going to tuck away this root proxy over in an admin namespace, right? So you just can't get to it. And then what I'll do is I'll delegate off portions of this path. Again, that's a different talk. We can dig into that later if you're all interested, but just to explain what's going on. So we'll create a namespace. We'll create this root proxy, and then we'll say, hey, marketing team, this is my example. I've got the marketing team. They're going to own this domain name, and we're going to give them /, right? So they can own the whole thing. And then in that marketing namespace here, what we'll do is we'll go ahead and we'll send traffic off to some application. What we need to do is send it to VMware. That's what we're going to do. We're going to send traffic basically to these two websites. These are my two web servers. We need a way to have this cluster know what those services are. And the problem is because it lives in vSphere. So let's go ahead and create a namespace. Let's just show you what I have here. Get namespaces. I have no marketing namespace, right? So let's go ahead and create that. We'll create a namespace called marketing. Cool. And then what I can do is if I do a watch, we'll get services and endpoints in the namespace marketing. You'll see these things popped in. They're 4 seconds old. So what happened is I've got Gimbal running in this cluster. And what it does is it goes out to the vSphere API and it goes and queries for all the things that exist. And what it does is it uses some metadata. So in each of these VMs, I've added some attributes here. And I've added this application, port, and project. And this is how I can basically tie a VM to something in Gimbal. So the project is basically the namespace that I'm going to tie this VM to. The application is the service, and then the port is the port we're going to direct traffic to, right? So with those 3 bits of information, Gimbal was able to figure out that, hey, I've got this application called blog and this one called web, and they both have endpoints. So these endpoints are the actual IPs of the VMs running in vSphere. So now that we have that, now we can send traffic to it, right? So we'll hop back here to this proxy. We didn't create anything yet, did we? So this is the service we're going to send traffic to. So now we've got Gimbal running. I'll just show you here again, marketing. Again, you'll see here that this service matches the service here. Now, the service is called web in vSphere if you click on that. But you'll see here in Gimbal and Kubernetes, it actually has this prefix called vSphere VMs. So that's just a name that we gave the cluster. So you have to give a cluster some sort of identity, right? Because in theory, I could have 100 different clusters running behind Gimbal, and they could all have a service called web. So this helps make things unique. So that's where this little prefix came. So that's all user defined. You can come up with that however you see fit. All right, cool. So let's go create some things. So we will go ahead and kube control apply our root proxy, right? So now if I come back to here and I get proxies, you'll see I've got 2 of them, right? And now they're valid. So again, this was the root one, which has my domain name, and this is the one in the marketing, in the marketing namespace here. So now what should happen is if I curl this pixelproxy.net, I should get directed to the VMs running in vSphere. Let's go ahead and do that. And I do. So this is a simple little echo server that I wrote, and it prints out basically the thing you hit. So it'll print out web01 if you hit the VM running web01, or web02 if it's hitting web02. If I refresh here, a lot of times, there you go, there's web02. Chrome will sometimes cache that connection for you. Let's get the idea, right? So now we're getting traffic. So traffic is coming in through MetalLB, hitting the Envoy pod. The Envoy pod then looks and routes based on this domain name. And then it hits the service in Kubernetes, which then redirects it back out to my vSphere cluster, right? So there's no applications running in Kubernetes at this point, short of all the infrastructure for Kubernetes to run in terms of user applications. So it's all running right now in the vSphere infrastructure. So here I can just proxy out, right? So essentially we've rewritten our own little software-based load balancer with Gimbal. Now we can direct traffic wherever we see fit, within the network. Cool. So let's go ahead and take that one step further. Let's go and add in another site. So again, if you saw here, I know I'm bouncing around. I hope this isn't confusing. We have this Windows box, right? And this Windows machine is running some old blogging software that we can't move to containers or anything. It's just got to run on Windows. So let's go ahead and send traffic to here. And let's give that team the /blog. So here we'll add a new condition to our proxy definition. And we're going to do this path-based routing now. So now /blog is going to route to this Windows machine, which is called blog. So any traffic to / will hit the vSphere VMs web01, web02. Anything in /blog will go redirect to this Windows machine. So let's go ahead and apply this one. All right, so we'll go ahead and get our proxies again. Just double check everything's healthy, everything's still valid. So if we hit the main one, / is still web01, web02, which is good. And now if we come to here and we hit /blog, we'll see we get the Windows box. So I intentionally left this here just because it's easy to know that this is IIS. So that's that machine, right? So now now I've got path-based routing. So /blog is again hitting the vSphere VM running over there. And then if I hit / in my request, you can see it still hits web01, web02. All right, cool. So let's go ahead and let's containerize those now. So web01, web02, I can containerize. It's a simple app. Let's move that over off of our VMware infrastructure into Kubernetes. So what we'll do is we'll go ahead and make a deployment. Again, so this is my app. I containerized it, and this is that same echo server here that I've got running. And again, the text I'm going to define is just say, hey, this is Kubernetes. So it's clear that we know which application we're hitting. And then there's a simple service here that we'll deploy as well. So we'll go ahead and deploy this. So again, just to be clear, I don't have any pods in the marketing namespace, right? It's completely empty. There's nothing running there. But when we apply this, we'll have some stuff. So we'll go ahead and apply O3 deployment blue. All right, so now if I get pods, now I've got my application running, right? So it's running now in Kubernetes, but nothing points to it yet, right? No traffic's going to hit it because we haven't configured that. So let's go ahead and do that. That's what we'll do here. So what we'll do now is we'll extend our proxy. So before we just had the single service for the vSphere VMs. What I want to do now is add the second one, which is the Kubernetes infrastructure. So now we're going to load balance across the VMware infrastructure as well as Kubernetes at the same time. And what I want to do is I'm going to do a canary-based deployment. So we're going to send some traffic and taper it off slowly from the vSphere VMs into my Kubernetes infrastructure, just to be sure, because I'm not sure if it's going to have a problem or not. And what I can do is I can add a weight here. So this is kind of where the proxy comes in. I can add a weight and say we'll give 90% of our traffic to the VMs, and we'll give maybe 10% to Kubernetes. So we'll go ahead and apply this one. All right, cool. So now we have that. So now if I go ahead and curl this, I should get web01 mostly, and eventually I'll get web02. There it is. So there's, I'm sorry, the Kubernetes infrastructure. And here we Kubernetified it so that we went from the VM into containers. Sometimes it's easier if I can do this. I'll do a while loop. Here we'll just curl it every half second. And sometimes you can see the requests routing back and forth a little easier this way. Again, 90% of the traffic should hit the VMs, and then 10% should be hitting the Kubernetes infrastructure. So about every 9 requests, it should hit Kubernetes. There it is. There's one going through there. All right, cool. So leave that run. And let's go ahead and we'll change this around a little bit. Let this run on the left, and we'll switch the weights. So maybe we'll go down to 50-50, right? We'll just speed it up. If I apply this again, so now we're going to give half and half. So it should load balance about the same between Kubernetes as well as the VMs. There it goes. So you can see it hitting Web 1, Web 2, and then also hitting Kubernetes. If we're happy with that, we can watch our Prometheus. We'll just jump ahead. We'll go 10 and 90. So now we can do 90% of our traffic to Kubernetes, which there it is. And eventually we should get just the Web 1, Web 2. There we go. Cool. And then once we're happy, we can just make this a 0 or delete it out, I guess. And now all of our traffic will go and hit Kubernetes. So we've completely moved from the VMs into Kubernetes. Yep. And we can just double check too. So this should all be Kubernetes, and it is. And if we hit /blog should still be that IS server running over Windows. So now we've got traffic splitting between 2 different places. So this is kind of cool. That was quick. I didn't want to spend too much time. I think that's all I have. If you want to find out more about Contour, you can ping us anywhere. We're at Contour in the Kubernetes Slack. Project Contour is the website. That's all I had. If there are any questions, we can chat or move on to the next thing.
I had one I wanted to point out, Steve, and I put it in the chat, but I noticed you used MetalLB as the load balancer. And since we're talking about load balancers, you mentioned you were using it in BGP mode. Yeah. So for anybody doing that, maybe we do have a couple other speakers, but if you can quickly point out the difference. And I want to mention to people, just because I got burned by it myself, that if you run this on vSphere infrastructure in L2 mode, which is a little different from BGP, you have to make sure you allow forged transmits and MAC address changes. Otherwise, it doesn't work.
Yeah, that's cool. Yeah, I didn't know that. So I'm not a VMware expert, which I know sounds silly, but yeah. So the BGP, you configure the peers. Actually, it's a good article I can send you. You configure the peers you want to send traffic to, and then the BGP requests will then get spun out, and the healthy nodes should be able to get requests. I think in L2 mode, only one node can be the incoming traffic, or can get traffic from the
Maybe
incoming.
You and I can think about a future blog post or something about that, because I looked at MetalLB and maybe I was wrong, but the docs led me to believe that I needed routers that supported BGP to hook up with it, and I didn't think I was prepared to do that, but maybe I misinterpreted it.
For L2 mode, you don't need that, but if you want to do the BGP one, you obviously you need a router that can handle that. Which Unify has just enough to do that, as you can see.
Yeah.
Yeah.
Okay. Anybody else got questions, or if not, we'll move on.
Yeah, I have a question. So for me, obviously Gimbal is new, but so is Envoy and Contour. I'm having trouble separating what each brings to the table, where one stops and the other begins.
Sure.
I don't know if you could maybe cover that in really basic terms.
Sure. Yeah. So it is confusing because they overlap a lot. So Contour is an Ingress controller. So its job is to route traffic from outside the cluster into the cluster. So when you can create, that Ingress configuration, or in our case, I showed you the HTTPProxy configuration. Its job is to actually route traffic. So you can, have a load balancer take traffic, and it'll actually go and route to an application. That's its job. Envoy is the component that actually does the routing, right? So it's a reverse proxy that it actually routes the data around. Contour is just the configuration server for Envoy. But sometimes we just kind of bundle it all together into Contour. But technically, Contour is just a controller which sends configuration changes to Envoy. So when you update your config, then Envoy can route the next request properly.
And you don't need Gimbal to run Contour, obviously. So if you have Ingress needs for your cluster, Contour is a high-performing, great solution for that, and a lot of customers are using it specifically for that purpose.
Let me take a crack at this, but Steve Sloak is the expert, so correct me if I mangle this and get it wrong. But the Envoy is kind of a base-level tool that does manipulation of flows. It was developed by Lyft. Contour is built on top of that to turn it into maybe a more full-featured control plane, to turn it into a functional ingress. And Contour is principally up at that L7 application level. So that's why Steve used MetalLB, I believe, because in some of these scenarios, you need the L2, L3, L4 things going on in addition or you want them. So Contour is a wrapper. And I think Gimbal was originally an external project that was sort of a control plane for Contour, but correct me if I'm wrong. And I've heard that the functionality of that has gotten merged into Contour.
Yeah, sort of. So again, Contour is just an Ingress controller. Its job is to route traffic. Gimbal is essentially a service discovery component in the way it exists today. So in the example that we showed, or I showed, we had all these different VMs running out here in vSphere. Gimbal's job was just to go find these VMs and then replicate, give service discovery into our Kubernetes cluster, right? So that we were able to reference it and send traffic to it. That's all it did. All the Gimbal's job is just to basically set up this service discovery. If I had another Kubernetes cluster that I wanted to proxy to, I could do that and have Gimbal then go find all the services and endpoints in that cluster. So it's basically just setting up service discovery for me so that I have those endpoints in my routing cluster. But Contour, like Michael said, its job is just to do route traffic. So you don't have to use Gimbal. Gimbal is just layered on top to then let us do this multi-cluster kind of routing. But out of the box, if you want just routing to a Kubernetes cluster, Contour itself will do that for you just fine. Is that clear? Does that help or?
Yeah, I think so. Yeah, a bit. Yeah.
If you need more, go on to the Slack channel for this user group and we'll help you out. Because sometimes this stuff, it takes more than a 1 hour meeting to really get comfortable with this. If you, in fact,
and hit our website, we have lots of demo videos from our website, projectcontour.io. We have community meetings that you can attend like every 2 weeks. Every week, alternating times. We have videos, blog posts. There's a lot of information to check it out. It's projectcontour.io.
Okay, if there's no further questions, Ashish and I hope I'm pronouncing your names right, and Manish are on the agenda to talk about the advanced load balancer roadmap. And they were a last minute ad, so I haven't talked to them myself yet, but maybe you guys can introduce yourself.
Sure. Yeah, we'll do. This is Ashish. So we're part of VMware, the acquisition VMware made in July last year of Avi Networks. So we are a commercial load balancer and Ingress solution for Kubernetes as well as VM, bare metal, public cloud workloads. So think of it as a solution that is gives you a uniform and universal applicability across all use cases. It's a software-only solution, and I will go into the details. If you can let me share. Okay.
I think I made you a co-host.
Yeah, you did. Yes, thank you. And in the meantime, Anand, my colleague Anand and Manisha also on the call. So if you want to introduce yourself, I bring up the slides.
Hi, my name is Anand. I work in the Avi Networks team as well. I'm primarily a lead for the controller in Avi. And I'll let Manish introduce himself as well.
Hey guys, this is Manish. I was a part of Avi acquisition, was the CTO for cloud infrastructure at Avi. But lately I've moved to the Transit Service Mesh team and work with Pere. A lot of you guys are here defining the future strategy.
Let me jump in a minute here too, because I think you guys are new to the Kubernetes user group meeting, but this group operating under the auspices of the CNCF is under ground rules that we don't use this for product pitches, but to some extent, you can acknowledge this whole group is about running on VMware infrastructure, which obviously is a product. So we can talk about what you need to do to get things to work. Like we're all about running any form of Kubernetes on top of VMware infrastructure, but we don't want to get into pricing or anything like that here.
This would be a completely technical. Yeah,
just wanted to make sure it was clear.
Absolutely. This will be a completely technical discussion, Steve. So.
Okay, great.
Right. So thanks for the introduction, Steve and Steve. I think it's a perfect setup. And what I'm going to talk about is the commercial option. So I think we talked about Contour and Envoy and potentially Metal LB. We have had a commercial solution in this space for a while, and we're making some enhancements. And so that's the perspective I wanted to give you around what that solution is, how does it work, and what are the environments where it might be a good fit. So at any point, if you have any questions, please stop me and ask questions, of course. So we think from 3 point of view, right? As when we look at Kubernetes, and at the end of the day, you're providing a set of application services, right? There's traffic management. So we talked about the load balancing and Ingress is definitely part of that. We talked about multi-cluster with Gimbal and even multi-environment. That's part of traffic management, IPAM, DNS, certificate management, etc. So all of that we talked about is part of the traffic management. Then there is security. Security comes from both encryption, certificate management, but also authentication, network level policies, whitelist, blacklist, etc. And then of course, observability. So this is the set of capabilities that in our view are relevant for any production large scale deployment. And when we started and when we looked at over the last year or 2 years, and let me just build this up, there are a lot of open source solutions out there which are good and great to begin with. But when we talk to large customers, some of the challenges that they've told us is that there are multiple discrete solutions. We just said there is a separate LB from an Ingress controller. Then there is a separate solution potentially for DNS and multi-cluster, and then IPAM, and then maybe security. Could be commercial, could be open source. And these create challenges around management, operations, lack of consistent observability across all. And then automation becomes a challenge as well because there are so many moving pieces that you have to automate. So what we have a solution that solves some of these problems is that it's a unified solution, it's an integrated solution. So I think we were discussing earlier, right? Some solutions have a unified LB and Ingress. We are one of them. So Avi, official name is NSX Advanced Load Balancer, but you don't need NSX to run it. You can run it in any environment, just the product name. So I'll use Avi for now. It's a unified LB and Ingress with the same solution, also providing multi-cluster, built-in IPAM, DNS, and security capabilities. There's built-in observability. It's a fully automated solution. So you control it through kubectl. You don't have to do anything outside of what you're doing today. So all the Ingress and LB, as well as the CRDs they'll be adding, you just use kube APIs to configure and manage it. So you get the cloud native automation, and I'll spend a few minutes on how it works in a minute. But you also get all the features and observability. Right? So that's the basic premise of why we have a solution in this form. At the high level architecture, right? So this is the same product that works across both container workloads and non-container workloads. So it'll be good to just understand high level architecture. So there is an Avi controller, and there is data plane called service engines. So think of data plane service engines are like Envoy. So they're the actual proxies, right? They're the actual load balancers. But the control plane is the Avi controller. And that's where that's a single REST API endpoint. Everything that you do is managed through Avi controller, and it automatically spins up these data plane or service engines, scales them out, scales them in. So it's a fully elastic. It's like an ELB-like solution where it horizontally scales out and scales in, provides active deployments, supports BGP, for example, for RHI. And so this service engine is both as LB and Ingress in one. And it can take a form of a bare metal, a VM, a container. It can run on-prem in vSphere, KVM, bare metal, or in AWS or in Azure or GCP as a native image. And so it's whichever environment you're running in, it can take the form factor of the underlying environment. Now I'm going to focus the next 10 minutes on just the container piece only. There are a couple of components, right? So there is the control plane we talked about. Additionally, there is a very lightweight operator. It's called Avi Kubernetes operator, which is the one which is similar to Contour. So if you want to map it to the Contour Envoy discussion we just did, AKO Avi Kubernetes operator is the Kubernetes Ingress controller, and it is listening to all the Kubernetes notifications when a services gets deployed. When a routes gets created or a service type LB gets created, it is the one that receives notification. It's deployed one per cluster. And then it then translates into equivalent RV APIs, which then deploys the data plane. So the slight difference here in the architecture is that the data plane are deployed in the underlying infrastructure cloud. They are not deployed as pods inside the kube cluster. We actually had that deployment model where the data plane, the proxies were deployed as pods, but there were some performance challenges with that. We have some customers running at 56,000 pods and 5,000 services at gigabits per second, and there were some performance issues as running as pods. So now we have a newer deployment model where they deploy as VMs or bare metals outside the kube cluster, but still have routing capabilities directly to the pods. And I'll get to that in a minute. And the last component is something called AMKO, which is the multi-cluster operator. And it's the one that is providing the GSLB equivalent functionality. So being able to program AVI for multi-AZs or multi-clouds or multi-clusters automatically. So that's the high-level architecture. Any questions before I deep dive into how this works from a developer point of view and a deployment point of view?
One thing I just noticed in a couple slides ago is you showed an icon for you. OpenShift is one of the Kubernetes solutions. So I gather this works with any
yes,
compliant Kubernetes. It doesn't have to be a VMware distro, but any one, including pure upstream open source.
Yes, pure upstream open source, any of the VMware distributions, OpenShift, Rancher, AKS, AKE, AKS, EKS, GKE, you name it, any Kubernetes.
Okay, so even you could use this even if you're in a public cloud, then it doesn't
Yes.
even have to be on-prem. Okay, great,
Right.
thanks.
So in fact, we have one customer, Deutsche Bank, and who's using us with OpenShift, and they are using us on-prem in 2 data centers and in Azure in 2 other data centers. So yes, they've been running about 50 to 60,000 pods for the last 3 years with AVI. So yeah, it's a very large-scale deployment solution.
Okay, thanks.
Right. So now let's double click on how this works, right? So let's talk a single cluster first, or a non-multi-cluster deployment first, and I'll bring the multi-cluster later. So there are 3 components, right? AKO, which is providing the translation of kube APIs into AVI APIs, and the AVI controller is managing the actual policies. That's the brain for the AVI solution, and the data plane, the service engines are the actual the proxies. So on day 0, you deploy through any automation, Terraform, Ansible, your own. You deploy AVI controller as a VM, cluster of 3. It could be vCenter on vSphere, it could be bare metal, it could be public cloud again. And it's anything, all of them are supported. And you configure whatever cloud you're deployed in, you configure certain parameters. So if you're deployed in vSphere, you configure it with the credentials for vSphere so that the controller can automatically spin up VMs and so on. If you're in AWS, you configure it with EC2 credentials so that it can spin up VMs, for example. And that's it. That's the infrastructure deployment. The next stage is every time a cluster gets deployed. So the AVI controller and its deployment is one time in your data center, for example. Then for every cluster, you deploy an AKO. And today it's a Helm chart-based deployment. We are working within the team, within VMware to do other form of deployment as well, including supporting a built-in packaging. But for now, it's a Helm-based deployment. And it's deployed per cluster. And what the AKO does is establishes the connection, a secure connection with the AVI controller so that it can start provisioning when it needs to. And now it's ready for app deployment. So this you do 1 per cluster at the beginning of a cluster deployment. Let's get that out of the way. Now imagine what, as Steve was showing earlier, in your deployment, you're deploying your services. As a developer, when you deploy, let's say your web services, and you configure a service type LB, or you configure Ingress. Remember, AVI is unified LB and Ingress. So there is a single hop solution, not a 2-hop solution. This is both performance and latency advantages as well as manageability advantages. So when the user configures an Ingress or routes, as well as CRDs, that's it. That's the only input that you have to give. Everything is fully automated. So what happens in the background is the AKO gets its objects from kubemaster. It automatically translates to the AVI APIs and programs AVI APIs. What AVI controller is going to do is it's going to actually first decide if it has enough service engines, enough proxies. If not, it's going to call the appropriate cloud infrastructure, whether it's vSphere or AWS or whatever it is, to spin up a set of VMs for proxies. Then it's going to plumb those VMs in the right network by talking to whichever the underlying networking infrastructure is. Then it's going to allocate an IP address for the VIP. Because remember, for the load balancer functionality, you need a virtual IP. So it's going to talk to whichever IPAM you've configured. AVI comes with a built-in IPAM, but also works with a third-party commercial and open source versions, including public cloud IPAMs and DNSs as well. So it allocates the IPAM, and then it programs the underlying service engines. It then also programs DNS. So again, AVI comes with built-in DNS, but you can use Route 53 or Infoblox or whichever your favorite DNS is. It auto-programs FQDN. It auto-programs the underlying proxies with the appropriate VIPs, and you're done. You can start running traffic. Now, earlier discussion on BGP versus L2, we support both modes. So of course, the scalable model is BGP. So the controller will program BGP, so that the service engines will inject BGP routes /32 RHI to the upstream router that it's paired with, and into active scale out to multiple service engines. Same VIP will reside on multiple service engine or can reside, and they share state around SSL states and cookie state and all that. So it's a fully distributed load balancer in an active form. And then the traffic, if you're an external client, you first look up FQDN, whichever DNS it is, has already been populated. You get the IP, it goes to the service engine, which terminates, which again, both load balancer and ingress. So terminates the TCP, SSL, HTTP, makes both the load balancing and the path routing decisions, and the traffic goes directly to the backend pod. And depending on the underlying CNI, most common deployment models are the CNIs that are routable, and we can go into that details, but we also support node port based through kubeproxy. But the most performant is if the pods are routable. Questions? This is just a high level how it works. We don't have time for demo, but we can set up another session if you want to go to a live demo as well. Any questions so far?
And just a warning, we technically have 5 minutes left or so. We could maybe go a little over, but we're running short.
Yeah, no, I know. This was pretty much the high level I wanted to cover. If there are no questions, I can cover a couple more things, but I want to pause here and see if there are any questions. Okay. Okay, so then I'll continue. Similarly, if you're a multi-cluster deployment, it's the AMKO piece, which then provides the multi-cluster or multi-AZ capability. Now, I do want to show one more thing here. Again, please ask questions if you have any. But I have a demo setup, and again, I don't have time to go through the detailed setup demo, but I can show you some of the analytics. So one of the key differentiators for us also is the built-in analytics. So here is what the dashboard looks like, where let me get this out of the way. Sorry. So this is the AVI dashboard. It's a fully multi-tenant system. So in Kubernetes, the namespaces would map to, or the projects and namespaces would map to a tenant in AVI. Fully role-based access control, full API-driven, built-in Swagger spec, all of that. And then for every application that you load balancing, we provide a significant amount of visibility and analytics. So in this case, this VIP is load balance on active across 2 service engines. The 3 path-based routing rules that have been set up here, pointing to 3 different pools. And then on each of the applications, we also get you visibility into end-to-end latency breakdown over the last 6 hours or day or week. So you can, this is built in, by the way, without any agents. It tells you, for example, what's the WAN latency, what's the local latency, what's the application latency, and so on. And you can get that at an individual transaction level as well. So I can open up any transaction, if it, for example, this one, and it tells me this traffic came from what location, so Nigeria, what kind of devices, what was the latency breakdown at each of these stages in the transaction, what are the URIs, and there's a ton of telemetry data that's built in.
So this is built in, but if I wanted to take metrics and feed them into Prometheus or some
Yes.
open source, is that available too?
Yes, in fact, it's in our GitHub. We have Prometheus connector, Grafana, Splunk, all of them, yes.
And getting back to just before this last segment, you said it was multi-cluster. Does that mean I could have components of some exposed service that for HA are hosted in different Kubernetes clusters where you've kind of federated them, or am I misunderstanding that?
No, you're right. So you could have some services running in one cluster, or different running in a different cluster, or it could be running in a VM or a bare metal, and you can do load balancing based on DNS or BGP, either way. Yes, and you can have consistent policy across all of the different applications.
I think that's unique. I'm not an expert on Kubernetes load balancer, but I think the standard built-in mechanism was designed for single cluster, or am I wrong about that?
I don't know. I'm not an expert in Kubernetes, but
okay.
I know that Anand, who's on the call, right? We are working on actually contributing to the community in terms of like the AMKO, especially the multi-clusters. We would like to contribute back to the community in terms of how we define those standards and what type of objects should be exposed. How do we make it native to also extend this to across multi-cluster and multi-environment, whether it's VM or bare metal. So that's something that we would love to participate in.
Okay, yeah. Why don't you follow up with me offline, because I'm pretty active in the Kubernetes community and the CNCF. So maybe we can get that going to turn this. So I gather this is commercial only, but with aspirations of taking it into an open source solution.
Right. So AKO and AMKO will be open sourced. The Kubernetes operators, the proxy piece is commercial, but I've also had chat with Michael, who's on the call, around how do we unify some of the APIs between AKO and Contour, and is there a way to have a consistent, so you can easily replace one with the other when you go from open source to commercial. So we are engaged in those kind of discussions as well, where how we unify some of these things.
So I can take the previous question, which is there is a effort as part of the federation, Kube Federation V2, there's federated ingress objects and federated deployments and federated services that tries to accomplish the multi-cluster ingress in some sense, but I'm not sure how widely adopted and used that is. And so we are doing a solution that we already had a GSLB solution, and we are doing the AMKO to just integrate with that directly.
So Steve, let's sync up on this, Manish. So there are these efforts going on to basically converge all of this together, like Ashish mentioned, and we are all sitting together between us and a few other folks. Let's sit together and we'll talk about it. Okay, great. Yep. So with that said, we're 1 minute past. I guess we can cheat a little because we started a few minutes late, but let's wrap this up. We had an item on the agenda. I wanted to talk to Robert about upcoming activities at the virtual KubeCon Europe, but I think that we're out of time. If there's a rush, we can talk about that in our user group Slack channel. Otherwise, we'll roll it into next meeting, Robert. Anybody else got any last minute questions, comments? Okay, with that said, I'm going to call this a wrap. Thanks everybody for coming. And if there are any subjects you want covered, throw it out there. What I'm trying to do with this user group is to make it work for users of Kubernetes on top of VMware infrastructure. So if there's something you've been curious about, want a session on, challenge me, because I'm willing to go out there and get speakers on whatever topics you want to hear about. Just put it in the agenda or mention it on the Kubernetes Slack channel and I'll make it happen. Thanks for coming. Bye, everybody.
Thank you. Bye.
Thank you.